All right, I'm going to go ahead and go over E1.2, which is the complex number system. When we're dealing with a complex number system, we have an imaginary unit, which we call I. Okay? And we define I, I'm going to say, is defined as the square root of -1. Okay? And we do that so that when we have square roots have negatives under them, we can pull that negative out as an I and be able to go ahead and calculate the radical that we're left with. Okay? Now if I is equal to -1, then that means I squared is equal to, if I square both sides of this, if I square the square root, it cancels. So I'd be left with -1. So I is equal to the square root of -1. I squared is equal to -1. It's the only time you can square a number and get a negative, right? So we're going to need to know these in order to simplify using complex numbers. Okay, standard form of complex numbers we write as a plus bi. Now if a, your regular number, happens to be 0, you don't have to write 0, plus bi or whatever. But if you have both a regular term and an I term, we always write the I term second. Okay. So let's go ahead and go over multiplying these numbers together. When we multiply, we always pull out the i's first. So I'm going to say pull out the i's first. Very important. Okay. So I'm going to go ahead and simplify these. If I pull out this I, I'm left with I square root of 2. If I pull out the I here, I'm left with I square root of 16. Now, I can simplify this. I don't have to multiply right away. I can go ahead and simplify. Square root of 16 we know is 4. So I have I square root of 2 times 4i. And then when I multiply these together, I can't multiply the 4 and the square root of 2 because one's under the radical, one's not. So that just becomes 4 square root of 2. But when I multiply my i's together, I get I squared. Oops, I meant to put that on the back. Excuse me. I get 4 square root of 2 I squared. And remember, I squared, we see from above, was -1. Okay, so I'm going to put over here, I squared equals -1. So this is the same as multiplying this radical by -1, which is just going to change the sign. So 4 times square root of 2 times -1 gives me -4 square root of 2. And then I just leave it like that. Okay. On the next one, when I distribute just normal FOIL or distribution property. The only difference is if I end up with an I squared, I have to remember to plug in -1 for it. So I'm going to go ahead and FOIL. 5 times 5 gives me 25. 5 times -4i gives me -20i. Then I'm going to distribute the positive 4i. Positive 4i times positive 5 gives me positive 20i. Positive 4i times -4i gives me -16i squared. So I'm going to go ahead and combine like terms. If I combine straight down, notice my I terms cancel, and I'm left with 25 minus 16i squared. Now don't forget, I squared is -1. So I'm going to go ahead and put a -1 in here for I squared and continue to simplify. If you don't replace that I squared, your answer will be wrong. So 25, that turns us into a positive 16, and then I can go ahead and combine 16 and 25, which gives me 41. Okay. Let me look at one more. On this next one, I want to go ahead and write this out and simplify it before I start distributing. Okay, I want to go ahead and pull out that negative as an I, and then I'm going to write this as 2 separate factors. So I'm going to write this as -5 plus square root of 3. Oops, I forgot my I. I'm going to write this as -5 plus I square root of 3 times -5 plus I square root of 3. So when I square a quantity, remember I'm doing that quantity times itself. So I'm going to go ahead and start distributing. -5 times -5 gives me positive 25. -5 times I root 3 gives me -5I root 3. If you put the I at the end, that's fine too. Then I'm going to distribute the positive I root 3. Positive I root 3 times -5 is again -5I root 3. positive I root 3 times I root 3 gives me a positive I squared root 9. Because I do square root of 3 times square root of 3, which is root 9. Okay. I'm going to draw my line and I'm going to combine my like terms, which gives me 25 minus 10I root 3. And then I'm going to do some simplifying on this one. Okay, square root of 9 we know is 3, and then I'm left with I squared. Okay, remember I squared, I'm going to go right over here again, I squared is equal to negative 1. So I'm going to put a negative 1 in here. Now when I put a negative 1 in there, 3 times negative 1, that just makes it a negative 3, which I can then combine with my 25 term. Okay, so I'm going to just rewrite this. So this gives me, move over here. So I would have 25 minus 10I root 3 minus 3, and then I'm going to combine my number terms. So 25 minus 3 gives me 22 minus 10I root 3. Okay? All right, so there is a couple for you to try, and then we're going to look at order of operations. Okay, so on the first one, we need to simplify first by pulling out the I and simplifying the square root of 4, which is 2. So when I write this out, that's going to give me x minus 2I quantity squared. So I'm going to go and write it as x minus 2I times x minus 2I. I distribute, combine like terms, and then replace my I squared with negative 1. Okay? When I replace it with negative 1, it makes that a negative 4 for my constant term. Same thing on number 2, there's nothing to simplify, so I just FOIL and then replace my I squared with a negative 1. Okay? All right, let's go ahead and move on, and I'm going to do a quick little refresher of order of operations. Order of operations, this tells us the order in which mathematical operations are to be carried out. Okay? You may have learned PEMDAS, okay, which is please excuse my dear Aunt Sally, or whatever, that basically tells us that we do parentheses and then exponents, and then we do multiplication and division, and then we do addition and subtraction in that order. Okay. When I say parentheses, know that this could mean any kind of grouping symbols. Okay. All right. And multiplication and division and addition and subtraction we do in order from left to right. Okay, so if there's addition and subtraction left, we work it left to right. Same thing with multiplication and division. So let's go ahead and look at a couple. Simplifying. Underneath my square root, okay, I have an exponent and I have multiplication. So I have no grouping symbol, so I'm going to go ahead and do my exponent first. So that gives me the square root of 9 minus 4 times 5 times negative 2. Now underneath my radical, I'm still working, my radical kind of acts as a grouping symbol in this case because it's going to be the last thing I do. I have multiplication. Remember we do it left to right because I have more than one thing being multiplied. So I'm going to go ahead and do negative 4 times 5 first. So I have square root of 9 minus 20 when I do these two times negative 2. Then I do my other multiplication, which is my negative 20 times negative 2, which gives me positive 40. Okay. Then I go ahead and combine my 9 and my 40, which gives me the square root of 49, which we know to be 7. Okay. Let's look at another one over here. If this looks familiar, it's because it's a quadratic formula, right, or pieces of it. But a lot of people have issues with messing their signs up, so that's why we threw this in. So on this one, I'm going to go ahead and work this piece the same way I did here, and then we'll worry about the rest of it later. So let's go ahead and do what's underneath here first. So I'm going to do negative 9 plus or minus the square root. 9 squared I do first, which gives me 81, minus 4 times 2 times 7, all over, and I could go ahead and do 2 times 2 because it's the only thing on the bottom, which gives me 4. So underneath my square root, I want to go ahead and multiply those three numbers together, doing left to right. So I have negative 9 plus or minus the square root of 81. Now negative 4 times 2 gives me negative 8. Negative 8 times 7 gives me negative 56. All over 4. And I keep going. combine my two numbers underneath a radical. When I do 81 minus 56, that leaves me with 25 all over 4. And then I know the square root of 25, right? Negative 9 plus or minus 5 all over 4. Now I want to go ahead and get my two answers on top, and then I'll divide them by 4. Okay, so negative 9 plus 5 gives me negative 4 over 4. And then if I do negative 9 minus 5, I get negative 14 over 4. And then I just reduce each one. So on the first one I get negative 1. On the second one I can reduce by 2, which gives me negative 7/2. Okay. So what would cause an expression to be a complex number? The only way we could get a complex number from an expression is if we end up with the square root of a negative. Okay, so if we end up with a square root of a negative number. Okay, because that's how we pull out an I. That's where the I's come from. So there's 2 for y'all to try, and I'll give you a little bit of time, and then we'll go over them. Okay, so I went ahead and go over these. On number 1, we're just simplifying. The one thing I do want to point out is when we get the square root of 76, although it's not a perfect square, it can be simplified. We can take out a 2 and we're left with a 19 underneath. And when we get to this point right here, notice all terms are divisible by 2. So you can either reduce all terms by 2 here, or you can factor out a 2 on top and then reduce that with the denominator. Okay, either way you should get 2 minus the square root of 19 all over 3. On the second one, we simplify and we end up with a negative under the radical, which means we take out an I. And then just like the last example, all terms are going to be divisible by 2 or reducible by 2. So again, I factored out a 2 on top here and then reduced the 2, which I forgot to make my marks showing that I reduced. There we go. All right, you can write it as 2 plus or minus I, or in my math lab it might have you separate it into 2 plus I and 2 minus I. The other thing I want to note that I messed up on is on this last example up here, we just had negative 9 plus this radical, and I changed it into a plus or minus for whatever reason. I'm not really sure why. But for the sake of not having to rework it, I'm going to go ahead and just change this into plus or minus on this example. If this minus hadn't been here, basically I would have just got the one answer, the one that I got from doing negative 9 plus 5. So my answer would have just been negative 1. Since I worked at plus or minus, I'm going to go ahead and put both answers. Okay. All right, so you can now do your E1.2 homework assignment in my math lab. Let me know if you have any problems.